All the comets that we can see from Earth are orbiting the Sun, but some belong to a special group called Sungrazing comets. Sungrazers are comets that come very close to the Sun at their nearest approach, a point called perihelion. To be considered a sungrazer, a comet needs to get within about 850,000 miles from the Sun at perihelion. Many come even closer, even to within a few thousand miles. Being so close to the Sun is very hard on comets for many reasons. They are subjected to a lot of solar radiation, which boils off their water or other volatiles. The physical push of the radiation and the solar wind also helps form the tails, and as they get closer to the Sun, the comets experience extremely strong tidal forces, or gravitational stress. In this hostile environment, many sungrazers do not survive their trip around the Sun. They don't actually crash into the solar surface, but the Sun destroys them anyway. Many sungrazing comets follow a similar orbit, called the Kreutz path, and collectively belong to a population known as the Kreutz group. In fact, close to 85% of the sungrazers seen by the SOHO satellite are on this orbital highway. Scientists think one extremely large sungrazing comet broke up hundreds or even thousands of years ago, and the current comets on the Kreutz path are the leftover fragments of it. As clumps of remnants make their way back around the Sun, we experience a sharp increase in sungrazing comets, which appears to be going on now. Comet Lovejoy, which reached perihelion on December 15, 2011, is the best-known recent Kreutz group sungrazer, and so far it is the only one that NASA's Solar Observing Fleet has seen survive its trip around the Sun. Comet Izon, an upcoming sungrazer with perihelion on November 28, 2013, is not on the Kreutz path. In fact, Izon's orbit suggests that it may gain enough momentum to escape the solar system entirely and never return. Before it does so, it will pass within about 40 million miles from Earth on December 26th, assuming it survives its trip around the Sun. All comets are great laboratories for scientists to learn more about our solar system, but sungrazing comets can also help us learn about the Sun. Their tails of ionized gas illuminate invisible magnetic fields, so they can act as a tracer, helping scientists observe these normally unseeable features. Such fields have even ripped off comet tails, allowing astronomers to watch them blowing in the solar wind, a wind that abruptly accelerates between 1 and 5 million miles from the Sun. Because of this, researchers will be watching Izon and other sungrazing comets very closely. Besides being interesting to watch, the images and data collected by NASA's Solar Observing Fleet can also help scientists learn more about the Sun itself. One of the biggest features that comets help reveal is the Sun's magnetic field. Since magnetic fields are invisible, we can only observe them indirectly, like using iron filings over a bar magnet. On the Sun, astronomers can look at where hot plasma in the Sun's atmosphere is trapped by fields to see their complicated loop structure. But farther away from the Sun, where the plasma is less dense, this approach doesn't work. Comet tails, with their ionized gases, are affected by magnetic fields, and so they can act as brief tracers. On April 20, 2007, Comet Encke had its tail stripped off abruptly by a coronal mass ejection that carried a strong parcel of magnetic field through the solar system. Even closer to the Sun, astronomers were astounded to see Comet Lovejoy's tail glowing in extreme ultraviolet light as it approached the Sun. They now think the glow is caused by energetic electrons in the Sun's corona interacting with oxygen from the comet. The glowing tail followed and illuminated some of the Sun's magnetic field lines. Careful analysis of the frames allows scientists to reconstruct where the field lines were, and even, to some degree, how strong they were. These comet tracers also illuminate small structures in the Sun's upper atmosphere, where they are usually too faint to be visible. Continued observation of sungrazing comets will also help astronomers understand how hot material in the Sun's corona cools, and where that energy goes. Finally, long-term observations of sungrazing comets will help us learn more about the solar wind. Some of the particles in the corona are traveling fast enough to escape and travel through the solar system. They begin moving at roughly 250,000 miles an hour, but start accelerating when they reach around 1 million miles from the Sun's surface. By 5 million miles out, they are traveling at up to 1 million miles per hour. The exact mechanism for this acceleration is not known. Comet tails that are blown off by the Sun travel with the solar wind and can act like a dye tracer in a river. Because they are made of different materials than the usual solar wind, they are distinct and easy to pick out, so they can show exactly how the acceleration unfolds. Because we are in a period of high sun-grazing comet activity, scientists can expect many more chances to watch these natural research satellites in the coming years. In fact, another large comet is expected to have a close solar pass on November 28, 2013. This comet is roughly the size of Hale-Bopp, so it should give quite a show. It will also undoubtedly be a treasure trove of information for scientists, and who knows what new solar secret it might unlock.